All right, so we're going to begin discussing the solutions from the mock exam that we took in class on Tuesday, May the 6th. So let's begin with number one. We have a very straightforward stoichiometry question. We have a 2.0 molar solution of aluminum chloride. So that's going to be AlCl3. So 1 mole of aluminum chloride will have 3 moles of chloride. So that's going to be 3 times 2 molar or 6 molar Cl minus. And so the correct answer is C. A lot of you guys got that one right. That's good. Want to bag the easy ones on this exam. Question number 2. We need to know what mass of NaCl is needed to make 250 milliliters. Of course, that is 0.25 liters of a 2 molar solution, and we're given the mass of NaCl is 58.453 grams. So just a little dimensional analysis, 0.25 liters times 2 moles per liter. Of course, liters cancel. And we know the molar mass, 1 mole, is 58.453 grams. 1/4 times 2 is 1/2. 1/2 of 58.453 is going to be 29.2265 grams. And so the best answer is going to be B, which is 29 grams. Number 3. We need to know the oxidation state of bromine in BrO3-. Remember that oxygen almost always, unless it's in O2, in which case it's 0, or unless it's in a peroxide or superoxide, in which case it's -1, will have an oxidation number of -2. And there are 3 of these, so oxygen contributes a -6. We're trying to find out what bromine should be, and the overall charge needs to be -1. So when we solve this, we find that bromine will have an oxidation state of +5. +5 is answer choice C. Number 4. We're going to dissolve ammonium chloride. It is endothermic. So we know 2 things because it's endothermic. Number 1, the temperature is going to go down. And number 2, the delta H is greater than 0. So we can eliminate answer choices A and B. We can eliminate answer choice C. The credited response will be choice D. All right, question number 5. Which gas has the lowest average molecular speed at 400 Kelvin? The largest, and by largest I mean the one with the greatest molar mass, will be the slowest. And here is our root mean square velocity equation. Our answer choices are krypton and molecular oxygen and SO3 and CH4. Quick calculation shows this is 16 grams per mole, and this is going to be 80 grams per mole. This is going to be 83 grams per mole. This is going to be 32 grams per mole. So the best answer is krypton. That is going to be answer choice A. Number 6. Molecular geometry of ICl4+. So the way that I prefer to do these is the easiest way. Central atom is going to be iodine that has 7 valence electrons. There are 4 atoms bonded to it, and I have to subtract 1 because I've lost 1 electron. And there are 2 electrons in every bond. This means there are 5 areas of electron density. That is going to be the trigonal bipyramidal family. And I'm going to have 1 lone pair, which I'm going to place here. The lone pair takes up more volume than the bonding pairs. And if you look at this structure carefully, you should see a seesaw hiding in it. Of course, I'm going to draw the lone pairs of chlorine as lines. So here's your plank of the seesaw. Here's the fulcrum of the seesaw. This has a seesaw geometry. And that is answer choice C. Moving along to number 8. Excuse me, moving along to number 7. We have ClO2 minus. Now, chlorine normally has 7 valence electrons, 3s2, 3p5. In order to make ClO2 minus, I must make more than 1 bond. And an electron needs to be added, but we're going to add that to oxygen. So what we're going to do is we're going to hybridize one of these electrons, which means we're going to promote it from the 3p to the 3d. Now I can make 3 bonds. I'll have 1 double bond with an oxygen, and I'll have 1 single bond with an oxygen, which will have a minus charge. So the hybridization is sp123 p3d. sp3d. You must use ODEC to do this, and if you use ODEC to do this, it's a pretty simple problem. If you don't, it's a pretty complicated problem. All right, number 8 we talked about in class during the review. There are actually multiple answers. Endothermic reactions are going to occur when we go from solid to liquid to gas. So when ice melts, that's endothermic. When CO2 sublimes, goes from solid to gas, that's endothermic. When iodine deposits, goes from gas to solid, that's exothermic. And of course, when aluminum foil reacts with bromine, that's also exothermic. So either A or B meet the criteria of the question. Either A or B. Moving on to number 9. We have equal molar amounts of helium and oxygen at 445 K. We know the kinetic energies are the same. So that means that 1/2 mass of helium times the velocity of helium squared is equal to 1/2 the mass of molecular oxygen times the velocity of molecular oxygen squared. Of course, the 1/2s cancel. And if I want to compare the velocity of helium squared to the velocity of oxygen squared, that is equal to the mass of oxygen over the mass of helium. Now, if these masses are molar masses and we take the square root, we get Graham's law of effusion. The larger molecule diffuses faster, effuses faster, moves faster. The smaller molecule is faster. The larger molecule is slower. So we know that the velocity of helium is going to be greater than the velocity of O2. And by the square root. So it would be the square root of 32 over 8. About twice as fast, actually. So the best answer will be answer choice C for number 9. Smaller molecules move faster. Okay, ground state for the copper ion. You have 1s2. Copper's got 29. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9 gives us 29. Let's get rid of all of these guys that are part of the noble gas argon. If I can completely fill a d orbital or half fill a d orbital, it's especially stable, so I'm going to promote one of these electrons to the d. And so the best answer, this is an anomalous configuration, is 4s1, 3d10, which is answer choice B. Answer choice B. All right, so if we look at number 11, we have the hypothetical element, the next great element, RT, which is rhodium, and we want to find its preferred oxidation state. So an ionization energy is the energy required to remove an electron. It will always be endothermic, and each successive ionization energy will always be larger than the previous. What we're looking for is the unusually large increase between ionization energies. So when we go from ionization energy 1 to 2, it is close to doubling. When we go from 2 to 3, it is not even doubled. It increases by about 1.5. But when we go from 3 to 4, it goes up by more than a factor of 3. What this means is that rhodium is most stable after ionization energy 3, so it will form a +3 cation, and that makes answer choice C the best response for number 11. Moving on to number 12. We have 2 milliliters of 12 molar HCl, and we want to make a 0.1 molar solution. There's a couple of ways you can do this. The way that probably everyone's most familiar with is M1V1 equals M2V2. So we have 2 times 12 divided by 0.1 equals the second volume. That's going to be 240 milliliters. Now, I have already have 2 milliliters, so that means I would need to add 238 milliliters. The best answer is going to be 240. That is answer choice B. Moving on to number 13. We want the correct name for P4O10. We're going to use the binary naming system, which is going to be tetra, phosphorus, dec oxide. This is the white portion on a match that you use to strike the match, and that is going to be answer choice C. 13, the credited response is C. Number 14. Which gas is most dense at 1.12 atmospheres and 323 Kelvin? What really matters here is that it's a certain pressure and a certain temperature are specified. Nothing else matters. From PV equals nRT, we know that the number of moles can also be written as the mass divided by the molecular weight. So if I were to solve this for m over v, which is density, I would get Pm over RT equals density, which is mass over volume. When the pressure does not change, that's a constant. Temperature does not change, that's a constant. R, of course, is a constant. I have a constant times the molecular weight is equal to density, meaning the molecule with the largest molecular weight has the largest density, and that, of course, in our choices is going to be xenon, which is answer choice D. Number 15. We have 3 bottles that have identical volumes at STP. Avogadro's law says that volume is directly proportional to the number of moles. Number of moles is directly proportional to the number of molecules. So the number of molecules will be identical when the temperature and the pressure and the volumes are identical. So the best answer is going to be credited response C. Number 16. The best Lewis structure for nitrogen monoxide. If we do the ODEC for this, first we'll do oxygen. Where I have the 2S and the 2P. Then I'll do nitrogen, 2S and 2P. One such structure has a nitrogen-oxygen double bond. Oxygen has 2 lone pairs. Nitrogen has 1 lone pair and an odd electron. I can do a resonance structure where the oxygen gets the radical and the nitrogen gets the additional lone pair. Those have formal charges though. The best answer is going to be this one, which is answer choice D. The real answer is they're both delocalized. Neither one of these are really correct, but the best Lewis structure, the most stable of those 2 structures, is going to be answer choice D. Let's finish up with number 17. And And in number 17, we have the following equation: CH4 plus Cl2 yields CH3Cl plus HCl. Now we're given bond enthalpy data, so we are going to break 4 CH bonds, 1 ClCl bond, 3 CH bonds will make, 1 CCl bond will make, 1 HCl bond will make. Now we can simplify this because really there's no need to break 4 bonds and make 3. We can simply break 1 CH bond, break 1 ClCl bond, make 1 CCl bond, and make 1 HCl bond. So the delta H in this regard, this is the third form of Hess's law, is equal to the bond energy of the reactants minus the bond energy of the products. The idea is, when we look at the cost of the reaction, how much energy does it cost to break it, and we subtract what we get back, if we get stronger bonds in products and reactants, it's exothermic and should have a negative delta H. And so a CH bond from the data table is 104. A ClCl bond is 58. A CCl bond is 103. And an HCl bond is 84. And when you simplify this, you're going to get minus 25 kcals per mole. And that is credited response B. So this gets us through 1/3 of the mock exam that you all took yesterday. So if there are any issues once you look at these, please let me know.